So when we're working with quadratic equations, we've seen one way to solve those quadratic equations is by factoring. So for example, if we had something like this, x squared plus 3x plus 2 equals 0, we could factor this into x plus 2 times x plus 1 equals 0, because 2 times 1 is 2, 2 plus 1 is 3. And then my two solutions would be x equals -2, x equals -1. But what we're going to run into sometimes is that solving by factoring is not always possible. For example, if I gave you x squared plus 5x plus 7 equals 0, if we try to factor this, if we try to think of two numbers that multiply to give me 7, add to give me 5, it's just impossible. The only way to multiply to get to 7 is 7 times 1, and that definitely does not add to be 5. So sometimes solving by factoring is just not an option. So if we ever encounter something like that where we cannot solve by factoring, then one thing we can use is the quadratic formula. So if we have a quadratic, ax squared plus bx plus c, then we can use this formula right here to help us solve it. It looks kind of complex and complicated, but really the gist of what you're doing is we're going to identify what's our a, what's our b, what's our c, and then all we're doing is substituting those values where they go and then simplifying step by step. And I'll show you the easiest way to simplify this. Okay, so example 466 is actually the same quadratic I chose up here. So we said, let me see if I remember, we said our solutions were going to be x equals -2 and x equals -1, I think. So let's see if that holds true. Okay, so if we're identifying my a, b, and c, that's what we're going to do first. I know my a is 1, my b is 3, and my c is 2. And sometimes, especially at the beginning when students are learning how to do this, I think it's easier to kind of write out the skeleton or the backbone of the problem, just putting parentheses where you see a letter. So I'm going to have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And notice anywhere there was a letter in the formula, I just put parentheses so that now we can fill in the blanks with our a, b, and c. So let's fill them in. X equals -b, or -3, plus or minus the square root of b squared minus 4 times a times c all over 2a. So now that we filled this in, let me show you the easiest way, in my opinion, how to simplify this. The very first thing you're going to do is type in this yellow highlighted part, not the square root symbol, just type in what's underneath your square root sign. So if we do that, we get x equals -3 plus or minus the square root. When we type this yellow highlighted part in, we should get 1 divided by 2 times 1, which is 2. Okay, once you've done that, we're going to see if we have a perfect square right here. See if we can take the square root of 1, which we can. It's a perfect square. So I get x equals -3 plus or minus the square root of 1 is just 1 divided by 2. So when we do have a perfect square, we're going to go ahead and find our two values. So we have the plus or the minus, so I have x equals -3 plus 1 divided by 2. X equals -3 minus 1 divided by 2. We've got to take into account it could be plus, could be minus. If we solve that top one, -3 plus 1 is -2. So we get x equals -1. For this second one, we get -4 divided by 2, or x equals -2. And if you look back up, that's actually what we got originally when we factored this. So definitely if it's factorable, factoring is much more efficient. We would prefer that method. But if you ever forget how to factor, or if we get to one that is not factorable, like we'll see in example 467, The quadratic formula is nice because it always works. No matter what the quadratic is, it will always work. Okay, so let's look at one that cannot be factored. Example 467. First thing we've got to do is write this in standard form where everything's on one side set equal to 0. So if I do that, I've got 25x squared minus 30x minus 11 equals 0. So my a is 25. My b is negative 30, c is negative 11. Okay, so same process. I'm going to kind of draw the skeleton of my problem. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, let's fill in our blanks. We've got x equals negative 30 plus or minus the square root of negative 30 squared minus 4 times a times c all over 2 times a. Okay, same process. Take what's underneath your radical, type that in your calculator just like you see it, and let's see what we get. We're going to get x equals negative 30 just gives me 30. Plus or minus the square root. When I typed all that in, I got 2,000 divided by 2 times 25, which is 50. Okay, so 2,000 is not a perfect square, but we can simplify it. So come over here to the side and use your factor tree to help you simplify it. To save time, I'm going to go ahead and show you what it simplifies to be, but you could start out like 2 and 1,000. 2 and 500, keep going, and then simplify that. So when we do simplify it, we get x equals 30 plus or minus 20 square root of 5, all divided by 50. Okay, we're not quite done here. This, and this can all be simplified. They can all be divided by 10. So I get x equals 3 plus or minus 2 square root of 5 divided by 5. That's going to be our answer. So notice when it is not factorable, we're going to have a square root in our answer. We're going to have an irrational solution. Okay, a few more examples here. For 468, I want to move everything to one side first. So I'm going to move my x squareds with my x squareds, my x's with my x's, my numbers with my numbers. So when I do that, I get x squared minus 2x plus 13 equals 0. So now here's the quadratic we're working with. My a is 1, b is negative 2, c is 13. So if we plug our pieces in, I'm going to go ahead and just write them in as I go this time. Again, it's not a bad idea to write the kind of skeleton first and then fill it in. But if we're filling it in, we get x equals negative 2, or 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 13, all over 2 times 1, or just 2. And one thing you need to be really careful of is if you're squaring a negative number inside of here, make sure to put that in parentheses. Okay, we're going to grab our calculator and type what's underneath our radical here. If we do that, we get x equals 2 plus or minus. In this case, we're going to get a negative 48 divided by 2. Okay, you might remember from a last unit or so that if I simplify the square root of negative 48, we're going to have an I, an imaginary number, in our answer. So I'm going to kind of think about this as 48 times negative 1, or the square root of 48 times the square root of negative 1. Well, we know the square root of negative 1 is just I. So now let's see how we can simplify the square root of 48. 2 and 24, 2 and 12, 2 and 6, 2 and 3. So I can take out a 2 and a 2. So I've got a 4 on the outside. Let me write this here. I've got 2 plus or minus 4. Well, we've also got an I on the outside, and then the only thing left on the inside is a 3. And that whole thing is being divided by 2. Okay, last step, we see if we can simplify all 3 of those numbers. They can all be divided by 2, so I get 1 plus or minus 2i square root of 3 over 1, or you could just leave it like this. Alrighty, looking at example 469. This one's already in standard form for us, which is nice. So my a is 4, b is negative 12, c is 9. If we plug those pieces in, we get x equals negative 12, or just 12, plus or minus the square root of negative 12 squared, minus 4 times a times c, all over 2 times 4, or 8. All right, if we type just the inside in our calculator, we're going to get x equals 12 plus or minus the square root of 0. That actually gives us 0 inside of there, divided by 8. Well, the square root of 0 is just 0, so we really get x equals 12 plus or minus 0, or just 12 over 8. That will simplify to be 3/2. So we just have one solution here, and that solution is 3/2. Okay, one more example here, and I want you to notice that we're kind of missing a piece here. We don't have our middle term or our b term, so we're just going to say that our b equals 0. So on this specific one, a is 3, b is 0, c is 7. So we've got x equals negative 0, or just 0, plus or minus the square root of 0 squared minus 4 times a times c, all over 2 times a. 2 times 3, which is 6. Okay, so if we simplify, we get x equals 0, or I'm not even going to write that, just plus or minus the square root of negative 84 divided by 6. Okay, similar to the square root of negative 48 like we did a little bit ago, let's come over here to the side and simplify the square root of 84. I'm going to write this as the square root of 84 times negative 1. The square root of 84, just go ahead and stick an I out there because we know the square root of negative 1 is I. So if we break this down, we've got 2 and 42, 2 and 21, 3 and 7. So I can take a 2 to the outside with that I, and I'm left with a 21 on the inside. So I'm going to write this as x equals plus or minus 2i square root of 21 divided by 6. We can simplify that just a little bit. Both of those are divisible by 2, so we get x equals plus or minus I square root of 21 divided by 6 divided by 2 is 3. So the quadratic formula is a little bit tedious. There's kind of a lot of simplification steps to it. But the nice thing about it is it always works. It does not matter if the quadratic is factorable or not. It doesn't matter if we have an imaginary solution or a real solution. It always works.